in 2002, I went to a talk at Novartis when they moved to Cambridge from Basel, Switzerland, and they described why this is ground zero. And it's funny, Allison's presentation was tremendous, and Quentin and Anthony's presentation was tremendous. And not only are lab PIs competitive, but states are competitive too. So at the time, Novartis was talking very eloquently about why this is ground zero, because we have the education, we have the clinical trials ability, and we have the research companies and manufacturing companies all located in the same area. And these were just pulled from MassBio for some of the ests that the mass biomedical industry represents. Very, very vibrant community in this area in all three phases. And not only are we very, very active in biomedical, as well as the education and hospitals that go along with that, but in energy efficiency, we're leaders as well. So for 5 years, Massachusetts is ranked as the #1 state in the nation. And thanks to our leaders, we have now negotiated one of the most aggressive 3-year targets, the most aggressive 3-year target for the next 3 years, because our new 3-year plan is in place. And a lot of people wonder, what is it when we get this ACEEE score to become #1 in the nation? And it's sort of a balanced scorecard. It has a number of different elements. How well do the utilities cooperate with encouraging energy efficiency, transportation, adoption of building codes, combined heat and power, state-led programs, and the appliance standards. And Massachusetts unseated California somewhere along 5 years ago, and we've maintained that seat. But one of the things we have to do is we have to maintain leadership in places like laboratories, which are very, very strong, strongly represented in our area. So you're all part of that, and if not us, who? And if not now, when? A little bit about Eversource. I think our brand is becoming more and more well established. But this shows you a little bit of our footprint over the New England landscape. And one of the things that you see in this is that in the utility business, it's very spotty. It's very town by town. Here we are in Cambridge, where we sell both gas and electricity. We go the next town over, we sell gas, and our teammate, National Grid, we sell electricity, and our teammate, National Grid, sells gas. We go to Worcester, which is represented here today. We sell gas, and our teammate sells electricity. And that's what MassSave is all about. When you hear MassSave, it's really the cooperation of the different program administrators, the different utilities working together. And Tom's up here with me today just to talk a little bit about how our programs work and how we can be a funding source for some of these projects. And so fixing a laboratory is not like fixing a light bulb. It's take one down, put one up, it's $22, and you know what the exact number is. It's a little bit more complicated than that. And so there's a bunch of engineering and things that have to go in to the implementation of what we call custom measures. This chart, or this set of blocks, represents some of the things that you could do that would make sense inside of a laboratory. Not all the things that you could do, but obviously it's a very active and vivid list. And the team is broader than just us and perhaps another utility, because there's a lot of engineering work that has to go into the development of what's possible, as well as the calculations of how much energy is actually being saved. The other thing that goes into these types of custom measures in laboratories is we're evolving our programs to realize that there's a lot of upfront engineering that has to happen before you even get started. You have to do a lot of engineering to understand what's possible. What types of chemicals and reagents are being handled in that laboratory? What kind of a mechanical design have you inherited? And what are you going to be able to potentially do in order to improve efficiency? The way we see it, the way we're evolving, these are not energy projects. They're laboratory projects that happen to have tremendous energy impact. And we're talking about spaces that may not have been properly commissioned and may have evolved in terms of what the occupancy is in the space. And so thinking about it, thinking about what type of a mechanical system do we have? What type of chemicals are we handling? And what's possible in terms of a reasonable air change rate and way of monitoring that space are really, really important things to work on. And it requires a lot of upfront engineering. So in addition to being a funding source for when that great energy impact happens, we are trying to help at the front end as much as possible in terms of doing the upfront scoping work, which I think is very necessary for these types of projects. We think that lab projects have a quadruple bottom line, and really energy is not the first thing on the list. These are buildings that are commissioned now and monitored. They're better than buildings that are just left alone and unknown in terms of what type of air change rates you have going on in that space. Air quality needs by space are really looked at and thought through. And then places like Harvard University can improve their infrastructure and reacquaint them with the funding source that they paid for originally anyway. And then, of course, there's all sorts of energy benefits, carbon footprint, and so on. I did want to say one other quick thing about Harvard University, and I think you can hear it when you hear Quentin and Anthony's talk, as well as some of the other content that you'll hear today. Even this space that we're in here in the Coughlin building. Harvard makes us better. And one of the reasons that Harvard makes us better is they've been doing this for a long time. When we pull everybody together that works on sustainability and energy efficiency in the Harvard campuses, it's at least 80 to 100 people that get invited. And the energy retrofits that they do in these buildings are sometimes the second, third energy retrofit that's gone on in that space. And so they're pushing the envelope. They're developing new things that other customers are not necessarily thinking about. So it's a very, very good relationship to be a part of. This is a case history that's on the MassSave website. And it's a good transition for me to hand the podium over to my teammate, Tom Coughlin from National Grid, just to say a few words about these programs as well.
Okay, so I've watched some of the other speakers with the visual aids here. Okay, you know, I had a lot of project information here, but you know, I was kind of inspired listening to the speakers this morning. Part of you know, establishing the whole culture of managing labs is really around establishing that culture within your own organization. So we had the folks, Alan and Mark, up from Cornell, and you could see exactly what they were trying to do behind the scenes, trying to set goals and actually see if they could benchmark themselves in further energy efficiency through a lot of what they did in operating labs. Engaging the occupants, very important. So Quentin and Anthony from Harvard, we could see a lot of that there where trying to make sure that there's some ownership with the people who actually occupy the labs day to day and inspiring them to take action is very important. But there's a lot of work. So I go to Allison's presentation, and a lot of the things that John's company, my company, and others like us have to deal with is the market barrier. So what's preventing people doing this? And if you take a look at some of the statistics Allison shared with us, if there are 20,000 labs in California, there are nearly as many, I'll say maybe 10,000, although one of the participants here today happen to say there's more like 8,000. So we'll say between 8 and 20,000 labs. That's a lot of lab space. This place isn't big enough to hold all the lab operators. So I look at all of you as being kind of early adopters, but we have a lot of work ahead of us, and you could see some of the things, some of the areas that we could make improvements on, like for instance, maybe through our energy efficiency programs, helping to advocate for more standardized refrigeration standards. So by adopting energy efficiency through Energy Star, eventually that might become a federal code, and that all refrigerators, all freezers have to be manufactured in that way, just like they are for our home appliances. Air management, very important, but to put it all together, you look at the major barrier that we face delivering energy efficiency to you, and that's that people think it's a good idea, and we saw this in Allison's slides too, but they don't quite know how to do it, and it certainly isn't important for their day-to-day business. Most important thing is that they have reliable lab work, that their process is reliable, that they know that it's going to be comfortable, and more important, that it's going to be safe if that's the lab environment. These are barriers that are not insurmountable, but to have the culture that the speakers that have already gotten up have in their own institutions certainly goes a long ways. But you take a look at that 10,000 or so lab space that's out there, that's a lot of square footage. They probably don't have the culture. Another barrier would be the split incentive, so you have the lab operator, the building owner, and unless the lab operator sees the benefit, they're not going to want to make these improvements. So anyways, I challenge you folks who are energy managers out there to think about how can you inspire them, the people that are using lab space, but maybe, how should I say, their rent doesn't reflect it. So that's a major issue for all of us to kind of take a look at. We're going to have some speakers on after us here that are going to talk a little bit about process and maybe some of their projects. So anyways, going into my slides, next slide please. I'll let the gentleman back there drive for me. So where do you start? The most important thing is that you give us a call. So some of you may have some new lab space coming up. What you need to do is call the local utility, or if it's not a utility, say you're in another state where it might be what we call an energy efficiency program administrator. Call them early on. Call them when your lab is in the conceptual design phase. That way we can get some of the services that we might be able to avail to help you decide what energy efficient options to choose from when you design a new facility. We hope we can say that we can take the lead, but actually what I like to think is that we take the lead from the design community. We only help them make more informed decisions for their clients. Next slide, please. I'm not even going to bother touching this thing. So anyway, I'm going to advance through these slides pretty quickly. Next slide, please. Next slide. Don't you like it when somebody presents like this? I only brought 50 slides with me, so you'll be here for a while. So if you take a look at the example that Cornell brought to us, a lot of different things that you can do with the lab. Many of you are already implementing them. Already, you know that controlling the air ventilation in a space is quite important. There are a lot of innovative technologies in lab ventilation. One of the barriers there, and you see it too, is trying to convince some of the lab people that they can do things like close the sashes. I think some of you have been caught up with that challenge, but also trying to make sure that they understand how they can manage the air, still be safe, save energy, and maybe even improve the comfort in the environment. We find LED lighting is something that you can see this space right here is lit with LED lighting. Certainly that's going to be a force to be reckoned with in the future. Again, when you're looking at ventilation, obviously you're making improvements that would affect your heating and cooling energy use by reducing the amount of air that you have to otherwise condition coming into the facility. It also helps your cooling and heating efficiency, and Allison had a slide on that. Vacuum pumps, there was a Tom, why is that name so easy for me to remember, who was sitting over here, who asked a question about what about compressed air and vacuum systems? Well, a lot of you may know that a lot of us are still using centralized compressed air systems it's a very good opportunity to have a distributed or not a centralized vacuum type system with smaller vacuum systems that might be wall mounted that serve very few by themselves, maybe up to 10 different lab spaces. Makes the space a little bit more able to be reconfigured, but also, by doing the distributed vacuum pump systems, you can make it more efficient, but also you might be able to provide a lot more control to the what goes on inside the lab space. So next slide, please. Next slide, please. Don't you love this? So anyways, I just wanted to show this example here. This would be National Grid, very common if you were to participate with Eversource, Unitil, and some of the other utilities throughout the region, whether it be Eversource in Connecticut, us in New York, or Efficiency Vermont in Vermont. Incentives could be as high as $750,000. That's the highest that we've paid for a very large facility. Always look for gas and electric incentives. By the way, if we were to help you analyze a facility, say, here in Massachusetts, although we couldn't pay an incentive on, say, oil heating, or if you happen to be in a municipal electric service territory, we may be able to help you quantify the savings so that you can put together that value proposition to make that decision. Next slide, please. I like this. It's much better than using this mouse thing. Just hold your finger up. So here's a project for a building built in 2005. 45% of the building was used for lab activities. 39,000 square feet, so it's right in that sweet spot where Allison was describing a typical lab space. And just by reducing the ventilation requirement by 46% for what they actually needed at the time they needed it, we're also able to overall reduce the electric use by 35% and 50% for the gas. So a lot of that is of course, the motor within, say, lab hoods, but also the interactive effect that it might have with the heating and cooling of the facility, saving $100,000 a year. Next slide, please. So anyways, high-performance hoods, I think some of you know this. I think that this was described in the Cornell presentation. If it wasn't, then I must have zoned out, and I apologize for that. But being able to retrofit your existing labs without reconfiguring your lab space, something that you can do. Next slide, please. Where do savings come from? Anyways, if you take a look at a lot of lab space, you might be running constant air volume, but by trimming that back, it can save significant energy. Next slide, please. So I'm going to finish up here, and then John, I think I'm going to turn it back to you so you can introduce the next guest. Write this name down. My lab person in my group is Fran Boucher. Give him a call if you happen to be doing business in our service territory, or in somebody else's. Give Fran a call or myself, and we'd be happy to, I'm getting the white card now. We'd be happy to refer you to the people who can help you. So thank you very much.